Explain the physics behind billiard balls, starting with the collision of two billiard balls, which is elastic. What is elastic collision? It is kinetic energy which is conserved before and after impact. We are going to explain this concept using Newton's first law. Body remains at rest or in motion in a straight line at constant speed unless acted upon by an outside force. For example, when a stick is hit by a cue stick, ball moves at a constant speed in a straight line. But in reality, due to the friction on the ball caused by the felt on the table, chalk on the cue stick, and air resistance, energy is transferred away from the ball. Or you can just say energy is lost. Now we're going to explain this concept using Newton's second law. F equals to ma. Net force of an object is equal to mass times acceleration. Acceleration and force are both vectors. Direction of applied force is present. So, increase in force equals to increase in acceleration, so higher collision. Now I'm going to explain this theory using Newton's third law. If a force is exerted on an object, an equal force is exerted back. For example, weight of a ball equals to the mass of the ball. Cue ball slides into the object ball at no angle. Thus, cue ball will stop dead regardless of the velocity. Let's represent the moving ball as green and the red ball as ball at rest. When a moving ball collides with a red ball, each ball experiences an equal force in the opposite direction. The moving ball moving to the right experiences a leftward force, it slows down, while the ball at rest experiences a rightward force, causing it to speed up. Since both moving ball and the ball resting have equal mass, they will experience equal acceleration. Thus, in a collision, a force on both objects causes an acceleration. The forces are equal in magnitude and opposite in direction.
The shot is performed by striking the cue ball just below center. This causes the cue ball to slide along the table instead of rolling naturally. Upon contact with the object ball, the cue ball's sliding motion stops, leaving the ball stationary.
Newton's cradle, how it works. Conversion of kinetic energy leads to no net conversion of kinetic energy into other forms. Starting with Newton's first law, body remains at rest or in motion in a straight line at constant speed unless acted upon by an outside force. We can apply the Newton's cradle concept using Newton's second law also. For example, F equals to ma. Net force of an object equals to mass times acceleration. Acceleration and force are both vectors. Thus, direction of applied force is present. So when force increases, acceleration also increases, making the collision harder. When the first ball strikes the second ball, its velocity is transferred to the third ball, so the first ball stops moving. The third ball then transfers the velocity to the fourth ball, thus the third ball stops moving. The fourth ball then transfers the velocity to the fifth ball. The fifth ball then moves.